Division of rational numbers. Division of any form of rational numbers ultimately becomes division of integers. Since rational numbers come in many forms, sometimes they are integers, sometimes they are in fractions, sometimes they are in decimals. So we will start with the simple form of rational numbers, which are integers, and let's divide 15 by 3. So let's write down the question that divide 15 by 3. Here we need to understand the terminology and the way we write this division questions. Divide 15 by 3 can equivalently be written in the form 15 and then divided by sign, and then we write 3. This can also be written in the form 15 and then this division bar and then 3. And on computer keyboard, if you divide 15 and then you can write 3. Now you can see that all these 4 different representations mean the same thing, that we are dividing 15 by 3. In this case, 15 divided by 3, when we use the division sign, the division sign will change into multiplication sign only if we reciprocate the number which comes after. Like 3, and what is reciprocal of 3? 1 over 3. Reciprocal mean to make the numerator denominator and the denominator as numerator. So we just switch over the numerators and denominators. In this case, there was 1 which was the denominator, which we usually don't write. So that's why its reciprocal is 1 over 3. And as we have seen in the multiplication of fractions, there is always 1 as the denominator. For 15, if 15 is an integer, then for multiplication of rational numbers, we can divide numerator with numerator. 15 times 1 over 1 times 3, and 1 times 15 is 15, and 1 times 3 is 3. And you can see that this form and this form is now the same thing. And this third method, that is just because this bar, division bar, is simply not available on the keyboard, so that's why we use this slash. And since since any number consists of the sign and the number itself, so while we are dividing, we are dealing with two things: the sign and the magnitude of the number. A mathematical number, or a more precisely irrational number, consists of sign and the number. For example, in this case 15, what is the sign for 15? Because we don't see any sign, so obviously that is plus sign, and if there is a negative sign, then that should be written there. But so we first learn how we divide signs. If we divide similar signs, like a negative number, whenever divided by another negative, answer will be positive. And if we have positive divided by positive number, answer is positive. And negative divided by positive, answer is negative. And positive divided by negative is equal to negative. So in simple words, if two similar signs divide, the answer is always positive. If opposite signs divide, then the answer is negative. This follows the same multiplication, same rule as the rules of multiplication, because division is just inverse operation of the multiplication. Anyway, let's get started and let's perform the actual multiplication now. In this way, if we were to divide 15 by 3, question number 1, if we were to write 15 divided by 3, how are we going to divide 15 by 3? Actually, we have to read the table of 3 until it reaches to 15. If that is the exact number that comes in the table of 3. We can't go over. So 3 one time is 3 and 3 5 times is 15. So there we go. We have now 5 over 1, and since we don't write 1 in the fraction form, if 1 is the only denominator, then we only write 5 as answer. So this is method you are going to, this is in fact used in converting fractions into its equivalent fractions. So just given fraction whatever is, we have to reduce it into the lowest form. So let's take another example, and in another example we are going to divide 460, question number 2, and this time we are going to divide 460 by 3. Obviously we can use other methods, but let's learn a long division method. Long division is a very famous method for performing the division. So this is 460 divided by 3. Now here 3 is the divisor and 460 is called the dividend. In other words, 460 is the numerator and 3 is the denominator. But if we were to do this by long division method, then we will write 460 inside and write the long division symbol and then write the 3 outside. So what is 3 is the divisor now, and 460 is called the dividend. So let's start from here and read the table of 3 up to 4, but do not go over 4. 3 only we can go up to 3. 3 one time, 3, and then we change the sign. Here it's minus. 4 take away 3 will leave behind 1, and then we take down the next digit, which is 6. So let's bring 6 down, and then again read the table of 3 up to 16, but you can't go over 16. So 3 one time, 3 2 times, 6 3 times, 9 3 4 times, 12 and 3 5 times is 15. Because if we go any more than 5, 3 6 times would be 18, which is more than 16, and I already said that we cannot go over this number, which is 16 in this case. So that's why 3 5 times is 15, and then change the sign and then perform this subtraction. 16 take away 15 will leave behind 1. again, there is one more number that we can bring down, and that is 0. So 3, read the table of 3 up to 10 again. 3 one time, 3 2 times 6, 3 times 9. We cannot go over, because if we do 3 4 times, that will be 12, which is more than 10. So we really cannot go more than 9. So again, we change the sign and then perform the subtraction. Here, this is 1, and this is what we did. This division, we performed this division by long division method. Here 1 is called the remainder. There is no more digit 2 which we can bring down. So at this time, so this is called remainder. Remember this. We will need this again and again. And this number after the completion, this is called quotient. So this will be called Q-U-O-T-I-E-N-T, quotient. So this is quotient, and this 3 is called the divisor. And this number 460, this is called the dividend. So these terms are very important, and let's do one more question. But before we do the next question, I would like you to take a look on the arrangement we can write. Here we can write 460 equal to the divisor, which is 3 times 153 plus the remainder, which is 1. So in fact, this is dividend is equal to divisor time quotient, T-I-E-N-T, quotient, plus remainder. And remember, this remainder will always be less than the divisor. So if we do one more question, that will probably help us to learn this concept even better. Here now we are going to divide 1139. Let's divide another question. 1139 divided by 1/4. It's up to you if you want to convert it into a fraction and then reduce it to the lowest fraction. If possible, that's good, but if we are doing it by long division, then we will be obviously writing 1139, which is dividend, and then we try to divide it with 14, which is divisor in this case. And now we are going to read the table of 1. Here the inside number 1 is obviously smaller. 14 cannot go into 1, so we include the next number, which is 11. 14 is still bigger than 11, and 14 cannot go into 11 because the inside number 11 is smaller than 14. Therefore, we include the next number, then it becomes 113. 113 is obviously a lot more than 14, so we are going to start reading the table of 14, and we will go up to 113. If we cannot get exactly 113, we should always get closest to 113, but we cannot go over 113. The maximum we can go is 14 8 times. 14 8 times is 112. If we try to go over, that number will be more than 113, and I already said that we cannot go over 113. So then we put the subtraction sign. We take away 112 from 113, which leaves behind what? 1. And then take down the next number, which is 9. This number. And now let's read the table of 14 up to 19. Very simple. We can only read up to 1. 14 one time is 14. And on the subtraction, this will give us 5. Now there is no more number which we can bring down. And interesting enough that now 5 is the remainder. If we were to find the remainder, then that's it. But if we want to precisely divide it and convert it into a decimal form, we can place a decimal here, and when we place decimal there, a 0 becomes available that we can add at the end of the number in exchange of that decimal which we have placed in the quotient. So now we can read the table of 14 up to 50. Alright, 14 1 time 14, 14 2 times will be 28, 14 3 times will be 42. So we can read the table only up to 3. That will be 42. We cannot go over 50. And if we try to go 14 4 times, that will be more than 50. That's why we have to stop it here. And now, what is the difference? Is 8. You can only place decimal one time. No more decimal. I mean, there is only one decimal that you can place. This time, as there is no more digit, so you can add 1 0 more, and then read the table of 14 up to 80. So 14 5 times would be 14 5 times would be 70, and this will leave behind 10. So if we continue, we can go like in this case we have divided with the accuracy of, in this case we say divide, we have divided 1139 by 14 with accuracy of 2 decimal places. 2 decimal places, and we finish this right here. And that's why we can say, if this was the question that divide 1139 by 14 with accuracy of 2 decimal places, that's it. But if you want to keep on dividing and increase the accuracy level, obviously then you can place one more 0 and read the table of 14 up to 100, and it will continue on. But this is how you can convert a given rational number. Well, you have learned the division. Also, it has helped you to convert a fraction into a decimal form. Because in the start of this lesson, we already said that fractions, there are fractions. We have to divide fractions by fractions. We have to divide decimals by decimals. But they ultimately become the division of integers. For example, if we take one more question and we say divide 1.5 by 3.2, then how are we going to write? We can definitely write it by like this. Solution 1.5 divided by 3.2. If we take that approach, then this is, we can write it as 1.5, and we change this division sign into multiplication sign. If we change this division sign into multiplication sign, the number which is followed by division sign, which is 3.2, we will have to reciprocate this number. And reciprocate mean 1 over 3.2. Okay, and now this will become 1.5, and you know there is 1 which is in the denominator, time 1 over 3.2, and here if we take a look, this would be 1.5 times 1 in the numerator, and in the denominator this will be 1 time 3.2, and of course this is going to be equal to 1.5 over 3.2. So even in the start, instead of writing 1.5 divided by 3.2, that's why I explained in the start that you can directly write 1.5, then this division bar, and then 3.2. And now, how we are going to convert 1.5 into fraction and this 3.2 into fraction. So if we want to convert 1.5 into fraction form, 1.5 and then divide, and then right below the decimal you can write 1 and count number of digits on the right side of this decimal. There is only one place or only one digit to the right of this decimal, so we're gonna place just 1 0 here and take away this decimal sign. Similarly, what was in the denominator? 3.2. If the 3.2 was in the denominator, we can write 1 right opposite to this decimal and then count the number of digits to the right. There is only one digit, so we place 10 here and take away this digit. And now our question is 15 times 10 over 10 times 32. So now you can see that 10 is obviously common. Anytime from this concept of equivalent fraction, if you divide the numerator by certain number and divide the denominator with the certain number, you can obviously, as long as the division is done by the same numbers, there is that's perfectly okay. So this 10 will be cancelled out and this will be left behind 15 over 32. And like I said earlier, that now division of decimal ultimately becomes division of integers, and here we are supposed to divide now 15 by 32, and if we want to convert this into a decimal, what is the dividend? 15, and what is the divisor? The divisor is 32, and because 15 is smaller than 32, we cannot go into 32, so we can place a decimal and add 1 0 right here, and then we perform the decimal. So 32 is 4 times. If we do it 4 times, so 2 4 times would be 8 and 3 4 times would be 12. This will be 128, and now perform the ordinary subtraction. So we borrow 1 from here, make it 10. 10 take away 8 will be 2, and 4 will be left behind. 4 take away 2 will be 2. Again, this number is smaller than 32. If you want to continue to divide it, you can continue the division up to whatever decimal accuracy level you want to take, but I'll just stop right here, and there we go. Okay. If we continue on this path, if we want to completely divide it and convert this fraction into decimal, then we have no choice. We don't have any more number to bring down, so we are going to add one more 0 and then read the table of 32, 30 up to 220. We can only go up to 6. And if we go up to 6, 6 times would be 12, and 1 will be carried, and 3 6 times would be 18, and 1 19. So this 32 6 times is 192. Yes, this will become 192, and then take away. And if we subtract, so we borrow 1 from here, this becomes 10, take away 2 will be 8, and then from 21 we can take away 19, and this will give us 2. And again, we don't have any number to bring down, we add one more 0, and we read the table of 32 up to 280. So this time we can go up to 8. 32 8 times is going to be 256. We cannot go over, so that's why we stop there. And take away 256 from 280, and that will give us 10 take away 6 will be 4, and 7 take away 5 will be 2. Add one more 0 here, and then continue to read the table of 32 up to 7. 7, and this time 32 7 times 7 is going to be 224. We can't go over 240, that's up to 224 is the maximum we can get. So now take away this, and then what is left behind is 16, and add one more 0 because there is no more number to bring down. So now if we read the table of 32 up to 160, it will go exactly 32 5 times will be 160, and there is 0 remainder. When there is 0 remainder, it means we have converted this fraction into decimal. So therefore we can say that 515 over 32 is equal to, we perform this division, and the answer is 0.4685. One more question. Okay, here is, now we are going to divide 2 by 25. Quickly, if 2 is to be divided by 25, then by using long division, we are going to keep 2 inside and 25 outside. So 25 is the divisor, 2 is the dividend, and let's see what is the quotient when we divide. So obviously this 2 is smaller than 25. We're gonna place a decimal here and add 0. It's still smaller. So we are going to add one more 0 here and then add 0 here. And now 25, read the table of 25, it will go exactly into 8, and 200 take away, that will give us no remainder, and therefore the answer would be 0.08. Remember, the division of integers by multiples of 10 is relatively, we don't need to perform this those operations by long division method. If any number is divided by 10, let's say 25 divided by 10, we can only place, because of this division of 10, we can place the decimal after one space. So this answer is going to be 2.5. See, this one, and here will decimal, and against this 0 we take away. Like if it is being divided by 10, place the decimal after one digit. If 25 was to be divided by 100, we place the decimal after two digits. So this will be 0.25. If it was to be divided by 1000, 25 by 1000, we were to place the decimal after three digits. But because there are only two digits available, so we can add one more zero on the left to make for three digits and then place the decimal. So on question for you guys, 4 over 10,000. So how are you going to write it? So there is only one digit available, but we have to provide how many spaces? 4 digits. So we can add 3 zeros and then we place the decimal. So this is how when we perform divisions by multiples of 10. In fact, if we revisit our previous question, which was 2 divided by 25. In another way, we could have done it like from the concept of equivalent fraction. If we multiply the numerator and denominator by the same number, that doesn't make any difference. So 2 times 4 over 25 times 4, that's perfectly legal. The reason we are doing it, we want to convert this denominator into multiples of 10. Now in this case it becomes 100 and 8, and like you have seen, we have to place the decimal after two digits. If there is only one digit available, 8, and then we can add one more zero and then we can place point, and in this case 0.08 is the answer. And same answer you got when you performed the long division, and you can compare those results. That's perfectly good. And now we are going to take a look on the division of a fraction by another fraction, which is mostly the case. I have seen many books, many websites where when people come to teach division of rational numbers, they usually emphasize more on fractions divided by another fraction. But let's take the example that if divide 5 by 7 by 3 over 5. So just like before, I said if we want to write its equivalent mathematical fraction, that would be 5 over 7 and then divided by 3 over 5. How easy it would be if we convert this division sign. If we convert this division sign 5 over 7 into multiplication sign and then reciprocate the fraction which comes after this. So now this will become 5 over 3 instead of 3 over 5. 5 over 3. You see we switched places here, and if we switch places, this division sign can be changed into multiplication sign. And now the multiplication of fractions, that is when we multiply fractions numerator with numerator and denominator with denominator, 5 times 5 over 7 times 3, and this would become 25 over 21. This again is simple case of division of one integer by another integer, and if you want, you can perform this division 25 and then keep 21, and I will leave this question for you to continue on. And another case of division of one fraction by another fraction would be if the fraction is mixed fraction. 2 whole 1 over 4 divided by 3 whole 2 over 5. First we convert this mixed fraction into simple fraction, and we know that we always multiply this and we add this. So 4 times 2 is 8, and then add 1, and then 4 is the divisor, divided by. Similarly, we multiply this and then add this number. So this would be 5 times 3 plus 2 over 5. So let's simplify this, this would be 9 over 4, and when divided sign is changed into multiplication sign, this 17 over 5 will become 5 over 17. And now it has become simply the case of multiplication of fractions. 9 times 5 over 4 times 17. So this would become 45. 8, 4, 7 times 28 and 68. This is, and now you can again perform this by 68, and I will leave it to you people for practice this and this. And another form of rational number is a recurring decimal. If recurring decimal 3.3 bar, if this is to be divided by another decimal fraction, let's say 1.68, we know that we can convert this into simple fraction, which would be in this case 10 over 3. You can look at my previous lectures where I have shown how to convert recurring decimal into simpler fractions. 10 over 3, and then this will change into multiplication sign, 1 over 1.68, and then 10 over 3 times this decimal is after, so this would be 100 over 168, and now this is equal to 1000 over 300 times 168. And of course you can multiply, and then that becomes case of division of an integer by another integer.